All right, so this is part 2 of the video for lesson 6.2. So we are going to continue talking about function transformations. If you haven't seen part 1 video, please go back and watch that one. Last time we talked about how transformations worked with quadratic equations. Now we're going to talk a little bit more about how they work with absolute value, exponential, and square root. And basically they work exactly the same. The transformations work the same. But there's just a few things I wanted to go over to help clarify and just go over a few more examples. So one thing, first of all, is I wanted to look at what those parent functions look like. So you're all pretty familiar with quadratics, and I know we've talked a little bit about absolute value, what it looks like. Exponential, on your notes here, I wrote f of x equals b to the x. We're only going to have you be working with one particular type of exponential function. So you can go ahead and write f of x equals 2 to the x. So we're only going to have you work with ones where your base is 2. So with exponential functions, you always have a base, and we're going to always just have that base be 2. And then lastly, square root functions, which we haven't worked with a ton, but I know you guys are familiar with it because we did talk about it a little bit. And I know you guys are familiar with how the graph looks, and hopefully you're also familiar with what the equation looks like. So one difference with these type than the quadratic is what it means to be inside the function versus outside the function. So in your practice, you probably got used to inside the function meant inside parentheses, and that's not always going to look the same for these 3 other types. So for example, in an absolute value function, inside the function isn't going to mean inside parentheses, it's going to mean inside the absolute value sign. So again, if you remember, inside the function for quadratic meant that it happened before you squared it, which meant we put parentheses around it and then squared it. Inside for an absolute value is going to look like keeping it in the absolute value sign. So it'd be x plus 2 in the absolute value sign versus f of x equals absolute value of x plus 2. So that would be the difference between being inside the function, applying something inside the function in an absolute value versus outside the function in absolute value. That one's not too hard to see. It does get a little trickier. I'm going to erase these so I have some room. It does get a little trickier when we get to exponential and square root. Let's do square root next. So square root, so our parent function is f of x equals square root of x. So to apply it inside the function, that means we're going to apply it to x before we take the square root of it. So that means it's going to happen under the square root sign. So if we do something before we take the square root sign, that means it's being applied in the function. So instead of thinking about is it in the parentheses, think about is it under the square root sign. Versus to be applied outside the function, it's going to be applied after you take the square root sign. And then for exponential, I'll write this one down here. We'll do it green. For exponential, again, remember, looks like 2 to the x. F of x equals 2 to the x. So to be applied inside the function, this is probably the trickiest one. It means it's going to happen up in the exponent space. And so if it applies in the exponent, it means it's going to happen up in that exponent space. That's what it means for it to be applied inside the function in an exponential function. So outside the function would look like 2 to the x and then adding a 2 there. So I just wanted you to kind of see the difference between what something looked like when it happened inside the function versus what it looked like outside the function. It's not always about parentheses. With quadratics, it always ends up being parentheses because you put parentheses around it before you square it. With absolute values, you have those absolute value bars that look very similar to parentheses, so I think it's easy to see. For square root, it's whether or not it's under the square root symbol, and with exponential, it's whether or not it's happening in the exponent space. So that's probably the hardest one. So So let's go ahead and do some examples. Let's go down to example number 2. All right. So let's look at what's going on. So first of all, it says identify the parent function of each function below and describe its transformation. So the parent function you can see is square root. So it's a square root. That's our parent function. And then we want to identify what's happening to it. So I'm going to just highlight different things that are happening. I have a negative there, and I have a +5 there. So I have 2 things going on. First of all, I'm going to look at what happens inside the function first. And nothing's happening under the square root, so nothing's happening inside. So I have no horizontal transformations. Then I'm going to look for vertical transformations. And I'm going to first look at anything being multiplied. I have that negative sign, so that means I have a reflection of a vertical reflection. So a vertical reflection. And then, I'm going to draw it over here. So remember, my square root looks like this. And a vertical reflection means it's going to flip upside down. So that means my new one is going to look like that. And then the last thing I have is I'm going to be shifted up by 5. Okay, so vertical reflection shifted up by 5. And so this red line then, let me see if I can do it, is going to move. Oh, nope, I got both of them. Let's try that again. Yeah, move up by 5. Okay, so that's what my new function looks like. And let's actually go ahead and go to Desmos and let's try that one, just because why not? Okay, so it was negative square root of x. And so you can see that was my first transformation. And then plus, oops, I have to make sure, move over so I'm not inside my square root still, +5. And there we are. So, yep, that's what I thought it would look like. And just for reference, I'm going to just put what regular square root of x looks like. There we go. So there's where I started, and there's where I ended up. And so, yep, I was pretty close. Okay. All right. I'm going to erase my graph, though, so we have room for this next one. Okay. First of all, identify the parent function. My parent function, hopefully you guys recognize that this is an absolute value function because of the absolute value signs. And this is one reason we want you to be able to recognize these different types of functions and their different forms. All right, let's look at what's going on with it. I have a lot going on with it. I have a 1/2 right here. I have a +1 there and a -2. So first I'm going to see if anything's happening inside the function. I'm going to look for things that are transformations that are happening inside the function. Those are going to affect it horizontally. So I have inside my function means inside my absolute value signs, and I have a +1. So that is going to shift me left. So shift left 1. All right, so I've taken care of that one. And then next I'm going to look at what's happening outside my function, and I have a 1/2 and a -2. And I'm going to first deal with the 1/2. And so that's a dilation. So it is smaller than 1, so it's going to shrink it. So I'm going to shrink by 1/2. All right. And then last, I have that -2 or the 2 that I'm subtracting. So that's going to shift it down. So I'm going to shift down 2. All right. So, and just for fun again, I'm going to try drawing this one. So again, I start off like this, and I'm going to shift left 1. So that's going to move me over here. And then I'm going to shrink it by 1/2. So that means I'm going to I'm going to kind of just draw a new one each time. It's going to kind of flatten it out a little bit like that. And then I'm going to shift down. Let's get a new color. Down by 2. So then I'm going to go down here. Okay. And let's go actually, I'm going to go back to the we're going to go to Desmos the other way again. So I'm going to show you, okay, so just like in the first video, I had a Desmos activity. There's another one. So again, you can go to student.desmos.com and enter this code, or again, there will be a link on Canvas. So I'm going to go to this one here and sign in again. Okay. And so this is exactly the same as the parabola one, except it's with absolute values. So let's go ahead and do that one that we did. So it was, we'll start with the basic one. We have absolute value of x. So that's our absolute value of x. But then we did, let's go in the order we did them. So first of all, we subtracted 1. Oh, nope, we added 1, didn't we? Let's check. Yep, it was an add 1. Okay. So we added 1, and then we times it by 1/2. So 1 divided by 2. Okay, so that's flattened it out. And then lastly, we subtracted 2, and that brought it down. All right. Cool. So let's go back to our notes. And you guys don't have to graph these, but I want you to kind of try to visualize them. You need to be able to at least describe what's happening. And so I think if you're visualizing it, then that helps. Okay, last one. First off, what is our parent function? So hopefully you guys see that the x is in the exponent. So that means it is an exponential. Function. So that's the parent function. And again, 2 is our base. So that's what that 2 in front is. So 2 isn't any kind of transformation. That is part of our parent function is 2 to the x. That's our parent function. And in fact, maybe we should write, instead of writing square root and opposite value, we should write what our parent function is. Our parent function is f of x equals square root of x. F of x equals absolute value of x. And here, f of x equals 2 to this x. All right, so let's highlight what we have going on. We have a negative in front of the x and a +3 after the x. And both of those things are also happening up in that exponent space. And since they're happening in that exponent space, that means they're being applied inside our function, which means they're horizontal transformations. So we're going to deal with the shift first. We're going to deal with the adding one first, because that's what we do first. We do this one first. So the adding one first is a shift to the left. So it's shifted left, shifted left 3, and then it is reflected, reflected horizontally this time. Or in other words, it's reflected over the y-axis. All right, I'm going to go up to the top to draw this because there's space up there and I already have the original graph, the parent function. Okay, so the first thing we're going to do is we are going to shift it. So I'm going to shift it 3 to the left. So it'll be kind of like that. And then we're going to reflect it horizontally across the y-axis. So that means we're going to rotate it left to right. And I don't just flip it, like I don't just twist it in place. I reflect it across this line. So it's going to end up looking like this, okay? I flip it across the whole thing. And so one point I wanted to make is if you did it in the opposite order, you would end up with the wrong graph here. And so I'm going to erase the green line. That's my intermediate step. So let's say if instead I flipped it first. So if I flipped it first, if I rotated it first, rotating it across the axis would give me this. And then if I scooted it over, I would have this. And so do you see how the blue line and the orange line are not the same? And so if I did it in the different order, if I rotated first and then shifted, it's different than if I shift and then rotate. And so I'm going to get two different graphs. And so if I want to get the correct graph, then I need to do it in this order that I show you here, where you start with your shifts inside, and then you do your reflections, all of your reflections, and then you do your shifts on the outside. So again, we're not going to penalize you for if you write them in the wrong order, but I do want you to be aware of it because it's just good to know how things should be. Let's go just back one more time to the Desmos activity. Again, this first page here, you can play around, you can try different things and see how it affects it. And then you can try going to the different pages and practicing again, seeing if you could match up the graph. So it works the same as the other activity. I highly recommend you try it. The absolute value button, just a little note, is annoying because as you see when you press it, you can see it knows that there needs to be another one, and so it will kind of put it there until you put another one there, and it'll get mad at you if you don't put it there. So just be careful. Sometimes it gets mad if you don't finish your absolute value pair. And if you try to write the one at the end before the one at the beginning, that's when it gets really mad. So hopefully that doesn't come up. But if you get confused, just try writing it from the beginning and it'll work out. So let's see. I want to move this one left and I want to move it down. So to move it left, I'm going to add 2 inside my absolute values. And then to go down, I'm going to subtract 1. And there we go. All right. So go ahead and try all the different activities and see if you can work on them. They do get progressively harder. Like that one, you can see is flipped upside down, or in other words, reflected vertically. Back to the notes. Oh yeah, one thing I wanted to point out, I know I said in the first video we didn't really talk about reflecting over the y-axis, and that last example that I showed you with the exponential function is the only example I've shown you so far where it is reflected across the y-axis, where we have a left-right flip. And part of that is because it doesn't really always make sense to write a quadratic that way, because, for example, y equals negative x squared, people usually don't write that because they could just write this and it's the same thing. Technically, they could write something like this, but they don't. They usually would rewrite it in a simpler form. And so it doesn't usually come up as often with quadratics and absolute values because they are symmetric. It's going to come up more often with exponential and square root. There is one example in the homework, though, with absolute value where there is a negative in the absolute value. Speaking of the homework, let's go ahead and look at that. So for the homework, there are a few more problems. So you're going to go ahead and do the rest of the problems that you haven't finished, 3, 4, 5, and 6. And again, most of them are just describing the transformations. So yeah, good luck, and remember to use your notes, and then we'll see you in class.